All right, another DraftPhysics.com, debatephysics.com also, but no one to debate. And so I have in the past requested of Fermilab that they would pay some attention to these subjects that I've talked about. And no, they won't. So you can't pay them either. So they probably do deserve a citing on the coward page because, yeah, they're basically cowards. Because they really won't name their price, and they really don't want these arguments to be made and have a public fight, because I think they're going to know they're going to lose the fight. All right, so on the subject of energy, all right, it's worth me doing just a quick, as always, description of this subject, I guess. I haven't watched the video, so. But they're talking about energy density in space, and the truth is that space has got a ton of energy in it. Okay, there's a ton of energy, and it's going in all directions. And frankly, the only way to measure it is to measure the rate at which it might oscillate something. But other than that, there's really no way to measure it because it's equal, you could argue, or so minor in one direction or another direction that how could you possibly measure the cell phones from Alpha Centauri versus us? Well, yeah, there's more cell phone calls, but that means there's probably more something else coming from some other place, so it all equals out. But there's no place in space where you think, oh, here's a place in space and it looks really quiet. There's no quiet space. Okay, it's just one that's not occupied by a piece of matter, or so I get rid of the matter, I still have all the forces. So because you get rid of the matter doesn't mean you can get rid of the forces. The force is still going through the area, so if I make the point even smaller, you get the idea that there's always stuff going through that piece of space. And it's just the rate at which it goes through, and so, but it's really hard to measure that because the only way to measure it is when there's a differential. When the energy makes something go this way and then it comes back and moves this way. So we need to kind of measure the oscillating rate, which is nearly impossible because you could argue the oscillating rate could be in the gigahertz. Anyway, so that's the dilemma. So the argument I would make simply is that there's always energy in the universe in every place, and it's only in two forms. Either in a space there's something moving, all right, a piece of force, let's call it, or there's a piece of matter that's being either pushed this way or pushed this way or pushed some other way by a collecting force. And that's it. So if the matter's moving fast, it means it's collected force in that direction, more than one Planck unit of it. And if it's moving slow, then it has very little force pushing it. But that's it. There's just matter and force. So there's free force going the speed of light and matter going some slower speed. SS. Anyway, but it's really that simple, frankly. But there's no idea that there's no energy in places where nothing moves. There's still plenty of energy. It's just that it's moving in both, just like us bouncing on the earth. Plenty of energy. It's just we don't see it because it, you go one way and then you go the other way and then you go one, you're oscillating in it. So that's the key word here, I guess, is oscillation. And the only way you could measure anything called energy density in the universe is to measure the rate at which it's oscillating.
A good scientific theory is one that makes precise and accurate predictions. We scientists are even happier when multiple theories agree with one another.
Whatever. You seem happy when it's as wooey and silly and stupid as possible, and you have live and dead cats and all kinds of other nonsense. That's when you really seem happier, frankly, is when the science gets as silly as a religion.
This gives us confidence that we know what we're doing.
Yeah, whatever. You never repeated the Eddington experiment, and you didn't do it from space. So you shouldn't have any confidence. You should be very unconfident because your evidence is so scant and thin. Your pool of evidence is very dry.
And, by and large, we do. However, there is one prediction in modern physics that is really, really bad, perhaps the worst in all of science.
It's too silly. Your notion that photons go through slits and are randomized is silly. It's really bad. A really bad prediction. In the sense that going through the slit isn't a problem. Hitting one of the surfaces, that's the problem.
I think it's time that I come clean and share one of physics' dirty little secrets.
Yeah, they're all dirty and they're all stupid and they're all not even secrets, and the whole physics is just a bunch of wooey nonsense. So it's just a religion. So that's all. This is just the, so he's not a pope, right? But he's the bishop of bullshit. Yeah, it's all very profound. Yeah, profound. We've conquered the world with our physics. All right, the worst prediction in physics. The worst predictions. I mean, you can go on and on, really. I mean, you're silly. Every time you use the word kinetic energy, you're making a bad prediction.
Modern physics can predict lots of pretty complicated...
All right, wait. So it doesn't really do any of this. So they keep talking about these predictions, but we never see the actual prediction. We don't ever see them calculate before they've done the experiment what the outcome is going to be. So that never happens.
Things like the aerodynamics involved in flying a supersonic jet and how a star...
And that's a lot of trial and error, obviously. So a lot of plane crashes before they actually got any of that crap right. So again, more blah, blah, blah. We predicted everything. No, you didn't really predict everything. You had to do it first and then find out, oh, I forgot about this variable. Oh, we forgot about that variable.
Star explodes. And, well, videos on both of those topics would be very fascinating. In this video, I'm not going to focus on the complicated. Rather, I want to talk about what seems like the simplest measurement in all of physics.
Right. It's obviously not the simplest measurement. It's one of the most difficult measurements possible, is to think about putting something between the moon and the earth in that place where there's no gravity, and then trying to measure how much force the moon is applying versus how much force the earth is applying. Newton would have a hard time, anybody would have a hard time figuring out what the constants were in such a circumstance, because nothing's happening, nothing that you can detect.
What is the energy density of empty space? So what do I mean about empty space?
Yes, exactly. Too silly.
I mean truly empty space. Nothing in it. No.
Yeah. Well, then there's no energy in it, so then there wouldn't be any density in it, and so, but it can't happen in this reality. This universe doesn't provide any places where there's no energy.
No people, no atoms, no electric fields, no gravity, nothing. If I could make a volume that is truly empty, then it seems pretty obvious that the energy density of this volume would be zero. Stands to reason.
Right. So you could say you could make some sort of perfect vacuum, and if you did that, you'd still be stuck with the fact that whatever vessel was holding it would have all this pressure pushing in. So you can figure out how much pressure is pushing in. So find out what the anti-pressure of your vacuum is, your energy vacuum.
And yet, when we turn our most modern theories to this question, we find
you turn a theory to the question.
That the energy density of space isn't zero. Let's see what the theories predict. The two theories that underpin all of modern physics are
nonsense and idiocy. Okay, so right. So two stupid theories. So he's doing the old bent fabric thing, which is a two-dimensional lie. And the rest of this nonsense, quarks, leptons, forces, whatever, blah, 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 all bullshit. A bunch of non-existent fake particles that, again, they don't do, if they were real, they wouldn't disappear in 1/trillionth of a second. They're not real things. They're things they say happen in the part they can't see. So it's all a kind of a gremlin theory. They're just saying a gremlin must have pushed on it.
Einstein's theory of general relativity and the standard model of particle physics. General relativity explains the behavior of gravity.
So it doesn't explain anything. It doesn't reveal anything that wasn't already known. So it's an inverse square law, so we know it's just like light, except in reverse. So it's just like a light bulb in reverse. right? If the photons went the other way and they were pulitons, that would be exactly the same mechanism as gravity. So we don't need bent space to describe what a light bulb does. Why do we need bent space to describe gravity? It's obviously just the opposite. It's outside pressure going in versus inside pressure coming out, right? Is that really that complicated? Do we need a whole different theoretical understanding to just run the light bulb in reverse? I don't think so.
Relation also includes the nature of space and time. Relativity is a theory that describes big things, cosmic things, the universe as a whole.
All right, so nonsense. It doesn't describe anything. It doesn't. They don't use it. You don't see it. It doesn't really play a role at all in any common understanding of relationships between things. Meteors crash into things. None of that needs any of this relativity theory. None of it has anything to do with anything real that's actually observed in the universe.
The Standard Model is the opposite. It focuses on the world of the small, the quantum, and subatomic.
All right, so I had the quantum that you don't believe in. So what's the point of saying the word? Because it's not a quantum theory. It's some other kind of weirdo theory with a bunch of weirdo things in it that do weirdo crap. Okay, there's nothing standard in the function. There's nothing consistent in the functions. And you're just basically saying that the smaller verse is much more complicated. So the simpler organisms in the evolutionary chain is somehow more complicated than the more complicated organisms, which is silly.
World of quarks and leptons and the nature of matter and energy in the microcosm. So what happens if we ask each of these theories?
Just hold on. Back. Okay, let's continue.
To predict the energy density of empty space. Let's start with general relativity. We learned over 100 years ago that the universe was expanding.
So again, they just keep saying this stuff, right? So the expanding thing is all based on the redshift thing. So this far away stuff is a little bit redshifted. And the explanation for that could be not that the stuff is flying apart or disappearing, but it could be that there's enough matter in empty space that when the photons are going billions of light years, they do in fact get scattered a little tiny bit by hydrogen atoms, and that little bit of scatter redshifts the light. So there's a simple explanation. I've never heard a great explanation for why that's not possible, but that wouldn't in fact cause the change in the redshift.
Just shy of 14 billion years ago, the expansion began. We call this process the Big Bang. And until a quarter century or so ago, we thought that the expansion was slowing down. That made sense. If you throw a ball upward, gravity pulls downward and causes it to slow.
So again, this idea that the expansion is still something left over from the Big Bang and that somehow it's been progressively expanding or something, and then they have that after the first millisecond it expands 400 million times, and I mean it's just convoluted mush.
The universe is basically the same, and therefore astronomers expected gravity to slow the expansion of the universe. However, in 1998 we discovered that
So it's much easier just to say the universe is its size and it's not changing size. It's a lot easier.
this wasn't true. Not only is the universe expanding, it's expanding faster and faster. The only way that could be true is if something was pushing the universe apart harder than gravity is pulling it back together.
So I don't know why they think it's faster. So I don't know what that approximation is based on.
The phenomena that provides this repulsion is called dark energy, and it's basically a repulsive form of gravity. Dark energy is essentially the energy of empty space, and it's very, very tiny.
All right, so again, it's just this made-up stuff that it comes from nowhere that pushes things apart. Fine, whatever. It pushes them apart in all the, obviously if you had two things getting pushed apart, they would end up pushing other things together, but there's no pushing together option somehow.
Converted to familiar units, dark energy is the energy equivalent of 4 individual hydrogen atoms per cubic meter of space. Dark energy is super, super tiny. Okay, that's what general relativity says. What does the standard model say? Well, the standard model says that even in empty space, completely devoid of all matter, electric fields, gravity, and whatnot,
All right, some impossible space to create.
it still contains fields.
So you just said there was no energy, so what are you saying? There's still fields. So what's the point? What's the point? What's the point?
These fields don't do much, they're just there. However, if they vibrate in the right way, the vibrations become electrons, quarks, and all.
All right, so this is where it all goes sideways and south and disgusting, that you can make matter out of nothing or energy. There's no real evidence of that. So, again, just storytelling.
All of the fundamental subatomic particles we study here at Fermilab. On the
So there's only 2 fundamental particles, electrons and protons. That's all there are.
other hand, if the fields are left alone, not vibrating in ways that make long-lasting particles, they still vibrate a bit, like a subatomic white noise generator. You might have heard about this sort of thing in a different way.
Yeah, I
Quantum
heard.
mechanics says that things
Yeah, I've heard of hobgoblins and pixies and trolls and and they have all that new stuff in that King movies, right? Or the Ring movies, whatever. So you got a whole bunch of new thingies. Yeah, sure. I heard of them. I don't believe in them.
like electrons are both particles and waves, which means that these white noise vibrations are equivalent.
No, it's just so bad. This poofy nothing. A bunch of poofy stuff turns into pooferiffum. And the pooferiffum turns into doofer-dooferism.
To very short-lived particles that are constantly appearing and disappearing. These particles are called virtual particles.
Oh, gee, it's just... oh, God, come on. Virtual. Why did you say fake? These turn into fake particles. Yeah, faux. They're faux particles. They're fake. Fake. We made them up. Yeah, that's right. Just completely made up fake particles.
And they don't seem like they're real, but we have lots of evidence that they are.
Oh, brother. They don't seem like they're real, but it seems like they are real. So it seems like they're not real, but from all we can detect, they seem like they're real. So I mean, it's just so bad. How could they seem both ways? Why did they seem unreal if you have evidence that they're real? Then how could they seem unreal if you have evidence that they're real? Shit.
The muon G-2 experiment here at Fermilab actually
Oh, geez, that sounds just as bad as it probably is.
probes this persistent quantum hum. I made a video on the idea, and the link is in the description.
Yeah, well, forget it.
The bottom line is that these
Bottom line is you're making all this crap up and pretending you have some sort of real science to back it up, real evidence, real experiments, real observations, and you really don't have any of that.
vibrating fields exist, and they contain within them some energy, which you can calculate. This is the energy of empty space. Now, when
You can calculate it. You don't have to measure it. Why do you have to measure anything? We don't have to measure nothing. We just calculate it. Theory in, theory out. Yeah, we don't bother with anything called evidence.
to do that, you have to add up the contribution of all of the frequencies of all possible vibrations, including shorter and shorter wavelengths.
Brother.
Since shorter wavelengths means higher energy, that means you add up higher and higher energies. A mathematician would say that you have to add up all wavelengths all the way down to zero length. But we know that the standard model fails for lengths shorter than the Planck length. I made a video on that, and the link is in the description.
Oh, brother. So, yeah, no, he makes a lot of videos that really aren't very interesting.
So what we need to do is add up the quantum hum for all wavelengths bigger than the Planck length, and this gives us the energy of empty space according to the standard model.
Yeah, well, why don't you just make up some kind of crap? Make a gigantic Newton's cradle, okay? And then you can make free momentum and call it empty space momentum.
And what you find is way more quantum energy density than you get with dark energy of the cosmos. The density is a staggering 10 to the 120 times bigger than the dark energy density. To understand just how big that is, that's equivalent to taking all of the mass of the visible universe, multiplying it by 100 quintillion, and then packing all of that mass into a cube, a meter, on a side. That's a big disagreement. On the general relativity side, the energy of empty space is equivalent to 4 hydrogen atoms per cubic meter of space, while on the standard model side, it's equivalent to the mass of 100 quintillion universes in the same volume.
Whatever. I mean, what sense does this make, this baby talk? Oh, shit. The two theories don't measure anything.
And that, as any precocious toddler would say, that's a lot. So that's the first message. Cosmic and subatomic theories give hugely different predictions for the energy density of empty space.
No, it's just, I'm sorry I made this video. Yeah, this is just ridiculous. So we've been shown nothing that would be called evidence that there's any measurement of anything, that they actually do some sort of experiment to figure out how much something moves in space without being moved. The non-moving movement. Ugh. All right, so let's try to say something relevant to this. All right, so this whole idea of this Big Bang and it explodes doesn't work as an explanation, because for the separation thing to happen, for things to go moving, everything moving apart, it's like that surface of the balloon argument. And then we'd be able to see it. We'd see that if we look this way and that way, things are moving apart really fast. And if we looked other ways, they aren't moving apart at all. So we would be able to see that. So it doesn't work as a theory. It doesn't explain anything. So, this is all breaking dimensionality. So really, yeah, I guess that's the real bottom line. These people don't really believe there's 3 dimensions of space and things are moving in those 3 dimensions and there's nothing more going on. There's 3 dimensions of space. Oh, shit.
Given that the discrepancy is so enormously different, something must be wrong. What could be causing the disagreement?
Well, because you have fable against fable. So you're mixing 2 fables and getting the fables aren't matching. I don't know. Garbage. I mean, you're comparing garbage to garbage. You're getting a wrong answer and a wrong answer and then saying, look, the wrong answers are wrong. The wrong answers don't agree. Yeah, well, duh.
Well, it could be that we don't understand gravity.
Well, that's a big one. Yes, you don't understand gravity at all. Simple mechanism. More pressure on the outside, less pressure coming out. So simple. More pressure goes in than comes back out. You end up with gravity. And where does the pressure go? Well, it goes to moving a whole bunch of electrons and protons inside the Earth. It has to constantly fuel the fire that's burning inside the Earth.
Could be that we don't understand the quantum world. Or it could be that
Yes, true.
there is some sort of physical phenomena that we haven't discovered that somehow cancels out that huge number from the quantum calculation.
Right, so those numbers are just ridiculous. The whole point is this expansion thing is ridiculous. If it was truly expanding for either reason, if we were being blown from some original center, then we'd be able to see the directionality. And the only way you wouldn't be able to see it is if you were still in the center. And we know we couldn't still be in the center because we would have been blown to bits. So that doesn't work. It doesn't work as a theory.
Which one is it? Unfortunately, the simple answer to that question is we don't know. A lot of explanations have been suggested, but none of them are accepted by the scientific community.
Right, and that's all that matters is the 12 people who get to decide. So the community of whatever, laureates, Nobel laureates, and whoever else you throw in there. And obviously it's always consensus, so if 6 out of 10 believe it, then everybody has to believe it. Yeah, fuck that.
Not only are none of them accepted by the community, there isn't even a consensus on the broad strokes of what a solution would be. Some ideas rest on the idea of quantized space-time, meaning that there's the smallest quantity of space and time like how
So it's time crap again. Time is not a dimension. You can't go there. You can't move stuff into it. You can't change it. You can't do anything to it. Time is just what it takes for the force to move from point A to point B, a position in space, point A and point B. It takes this long for the smallest entities in the universe to travel the distance. I mean, it's not that complicated, really. There's no time dimension.
a grain of sand makes up a desert. Other ideas invoke additional dimensions of space.
The time one is already an extra dimension, so you've already fucked it with the fourth dimension, let alone adding any others that make no rational sense.
Dimensions that can't be seen, but mean that the equations of the standard model are overlooking some super important factors. My own personal guess
Energy from some other universe. I mean, just too silly.
is that when a proper calculation of the contributions of the various fields that hum in empty space is done, that the effect
So there's no experiment. They don't detect any hum of space. This is just bullshit.
effects of some will be a positive energy and some will be a negative energy, and they will.
Oh, fuck. Negative energy. The unenergy. I mean, it's just so bad. Unenergy. What the hell could that possibly be?
End up pretty much canceling each other out. By the way, you shouldn't believe that idea. I certainly don't. It's important for a scientist talking about speculative ideas to remember to.
Well, why didn't you say all of this is just speculative crap, and so none of this has anything to do with any kind of real thing called science, and you're just making up bizarre theories that where you're bound by no limitations. You can just make up any kind of nonsense. You might as well change your name to Johnny Cochran.
Not believe what they think. And you should keep in mind that even if I'm right, there's still a problem. It's one thing for two fields to cancel exactly, like +1 and.
Ah, there you go. Yes, that's right. There's energy going one way and energy going the other way, and you end up just oscillating in the energy, and you don't go anywhere, so you don't go zero change in your position. But they didn't cancel. They both applied their plus on you, and then they applied the minus on you, the left and then the right.
-1 add to 0. But with the field idea, the plus and minus quantum fields almost, but don't quite cancel.
So says you.
After all, we're left with dark energy. This imperfect cancellation is a problem that remains unsolved. I put a link in the description to an accessible article on the topic.
Oh, brother.
It explores some of the ideas, but you should be aware that every single one is a bit on the crazy side. I say crazy, but crazy isn't always bad. Indeed, I'm fond.
No, whatever. Say again, more crap. That's not science. Science isn't crazy theories. Crazy. It's supposed to be a sincere effort to find this Occam's razor simple answer to what is basically the simple question.
Fond of a quote by Niels Bohr when he heard a lecture by Wolfgang Pauli. In the question and answer session of the lecture, he is reported to have said, "We all agree that your theory is crazy. The question which divides us is whether it's crazy enough."
So, of course, that sounds like a perfect Bohrism. I mean, he's always just making up excuses to be phantasmagorical morons. Go ahead, suggest God did it.
No matter. The real thing is the mystery. As Sir Arthur Conan Doyle wrote in The Return of Sherlock Holmes, the game's afoot. And if you're some bright young lad or lass looking to make it.
So now they're just going to be patronizing. Oh, let's see if you can come up with a theory for, why photons create a fringe pattern. When mathematically it's clear that it's the surfaces that are causing the phenomenon. Clearly, that's the only math that works, is the math that measures the distance between the surfaces. Yeah, see if you can come up with something better than entanglement and ESP particles. Shit.
Aim for yourself by solving a question that has eluded some of the best minds in physics for nearly a century. This is a good one to work on.
There's no point in working on it, because you have no frickin' experimental data to work with. You can't measure this crap.
I mean, who wouldn't want to be the person known as the one who resolved the worst prediction in all of science?
Oh, fuck. So it's obvious they got a lot of bad ones. And the very concession that they have a lot of bad predictions is in the idea of a worse one. So we have other predictions that are pretty bad also, no doubt. But whatever. Oh, I just hate this shit.
Okay, this topic is a fascinating one. Two of the most successful theories of all time disagree very badly. Fascinating and frustrating stuff indeed. If you enjoyed learning about this dirty little secret of science, be sure to like the video and subscribe to the channel.
So I'm amazed that they still have to do this crap.
There's lots of stuff to learn about physics. Lots! After all, physics is everything.
Brother. I agree, but it's all in the small universe. There's no big universe, and the small universe is poorly described by you. Very poorly. So anyway. Enough of that. So, it actually has a producer. Ian Crash. All right. So anyway, that's enough. There's not much you could say, right? It's just this is all their theoretical crap based on so little information, and they just make up these stories and expect reasonable people to believe it. And unfortunately, people are sheeple, so they do believe it. So anyway, till the next time and such and so forth and whatnot. It's very disappointing. The world runs on this crap.